So last time we were discussing change in right hand side, right? Change in right hand side. So I have told you that when we are changing the right hand side, we will change only XB, that will be my B inverse B, and obviously your Z will change, that will be your CB into your XB, right? So we have found that in the second part we have given that my right hand side has been changed into this. So we have obtained this solution. So when we will put this right hand side here in the optimal table, so now you can notice that our right hand side that had was now it is coming as your 11, 23 and -4. So we have to find the optimal solution. You can notice here that this is not my optimal solution. Why it is not optimal solution? Because the solution which is given to us is not feasible, right? So that means we have to apply dual simplex method. That means this will be the leading variable, right? So we have to find the minimum ratio, that is of your Zj minus Cj divided by beta j, and your beta j should be less than 0, right? So that means that will be my entering variable. For this variable I'll not find, for this I will not find, for this only this is the minimum element. So this will be my pivot element. What I have to do with the pivot element? I have to make this as Z1, this as 0, this as 0, and this as 0. So you can start with your simplex iterations. So here will be my Zj minus Cj. Now my x2 here, x3 here, and s1 will be here. If you will apply your row transformation on the third, that will be r3 by -2. So this entry will become your -1. This will become 0, 0, 1. This will become your entry -half. This is -half, and this entry will become as your 2. And again, you will apply your row transformation on this. That will be your R2. That will be R2 minus your. This is already 0, so we need not to do with this operation. This is 3 by 2, 0, 1, 0, half, 0, and this is 23. And you have to apply your row transformation to make this as 0. So R1 will be your R1 minus half times your mu R3, right? So what it will become? It will become, this is your entry 1 by 4. If you will apply, this is 1, this is 0, 0, 0, this will become 1 by 4, 10. You have to make this as 0. So you will apply your row transformation, that is R0 minus 1 times your mu R3. So this entry will become your 5, 0, 0, 5 by 4, sorry, 0, because we have to make this element as 0. This is 5 by 4 and half, and this entry will become my 1. Earlier it was 137, right? Because it was given. Here it was 135, right? Now you can calculate this. This is nothing but CB into your XB. Now CB is your 3. CB is X2 cost coefficient is 2. X3 cost coefficient is 5. S1 is 0 and it is 10, 23. And this is 2. So this is nothing but 20. So in the initial table, it was given as 137, because when you will calculate CB into XB, this is coming out to be your 137. And this you will calculate, this is coming out to be your 135. So now you can stop at this iteration because your all Zj minus Cj are greater than 0. So here your x1 is 0, x2 is your 10, and x3 is your 23. This is your optimal solution, and the optimal value here is your 135. The next question is that within what range we can change the right hand side of the first component. So that means the next part which we are doing, that is my third part. So I can take, let the first component of right hand side be B1. So that means I have to calculate my XB. That will be nothing but my B inverse into B. B inverse we have already calculated. That was your the columns of S1, S2, S3, 0, because initially that were slack variables. This is -1/4, 1/2, 1, 0, 0, 1. And now B is your, this first component is B, second is your 46, this is your 42. When you will multiply, you will get this as B 1/2 minus 23/2. This is coming out to be your 23. This is coming out to be your 2 minus 2B1 plus 88. So that means the question is given to you that optimality should not be disturbed, right? If the optimality means optimal basis should not be disturbed, optimality will need not disturb if my XB will be greater than equal to 0. This is okay that this is greater than 0. That means my B1/2 minus 23/2 should be greater than equal to 0. And minus 2B1 plus 88 should also be greater than equal to 0. So from here you will get B1 should be greater than equal to 23 and B1 should be less than 44. So what is the range? That if you change your first component in the range 23 to 44, your optimal solution will not change. So this is all about when we can change in right hand side. Next we can go change the question, change this as well. Initially in the table when it was given to you, it is 137. In the previous example also, when you will multiply CB into XB, it is coming out to be your 137, not 135, right? So next part which we are going to do, the third is that we are going for addition of variable. So when we are doing addition of variable, obviously what I need, the cost in the objective function, right? And I need the column related to constraints जो अपने constraints में add करना है. This what I know. So when I have to perform the iteration, so what I need to calculate for the variable. So for the variable, I just need to calculate its alpha j. That means it is the column in your simplex iteration and nothing but your zj minus cj that we will calculate. What is the formula of alpha j? That is nothing but B inverse your aj, that is the column of aj, and zj minus cj is nothing but that is your cb into alpha j minus your cj. So we will start with the example. So the example is if you have a question like maximization z, that this is minus 2x1 minus x2, right? Subject to, you have constraint 3x1 plus x2 is equal to 3, 4x1 plus greater than equal to 6, x1 plus 2x2 less than equal to 3, and the optimal table is, which is given to you. So when you have solved this problem, you might have added first artificial variable in this. This was your A1, and second artificial variable in this A2, and obviously you have added your slack variable. Surplus variable in the second, the name I am giving S2 and this is my S3. So the solution part Zj minus Cj, and it consists of your X1, X2, S3. The cost coefficient for X1 is -2, this is -1, this is 0, and this is coming out to be 1, 0, 0. 0, 1, 0, and obviously this will be 0, 0, 1. This is coming out to be 3 by 5, 6 by 5, 0, and this is coming out to be minus 12 by 5. This is 0, 0, 0, and this entry is coming out to be 1 by 5 minus 2 by 5 plus m. This is coming out to be minus 1 by 5 plus m. This is 1 by 5 minus 3 by 5, 1, and this is 3 by 5 minus 4 by 5, and this is your 1. Suppose if this entry is not given to you, then this obviously corresponding to this negative of this, that is minus 1 by 5. Why? Because you have added surplus variable and the behavior of your artificial variable just opposite to your surplus variable. Minus 1 by 5, 3 by 5, and this is coming out to be your 1 by minus 1, right? So now the question which is given to you, they have given the question that if a new variable with cost minus half is and 052 column is added in the constraint, then find the optimal solution. Then find the optimal solution. Now you know, whenever we have to enter my basic variable, I have to enter any variable into this simplex table. I need to just calculate my alpha j for that. And alpha j means I have to calculate, firstly I am assuming let the new variable be, let the new variable be my x3. So that means now when you have given, so the coefficient for x3 it is given to be that this is minus half into your x3, and it has given that the column this is 0, 5, 2. That means this is my nothing, this is my plus 0 into x3. Here it is plus 5 into x3 plus 2 into x3. So this is the column of A. So I'm taking new variable. So if I have to make a column or entry over here that this is my x3. So what I have to calculate? I have to calculate its alpha j. That means I have to calculate these entries. And I have to calculate zj minus cj. So how do we calculate your alpha j? That I am calculating alpha j for x3, right? So it is, I am calculating, this is my B inverse into AJ. That means AJ means the column of X3. So B inverse, you can say this is optimal table given to you, and correspondingly to that, whenever you have added, when you have started this problem, you have taken A1 as your basic variable. So firstly, initial basic variable. So this means this will be my first column of your B inverse. A2 might you have taken this. This is A2. This is A1 entry, column of A1 entry, and the column of A2 entry. And your initial is S3, that is 0, 0, 1. So now AJ column which you have to enter, that is you have given 0, 5, 2. So if you will calculate, this is coming out to be your minus 1, minus 3, right? So means these entries are my minus 1, 3, and this is my minus 3. Now what is left? Just we have to calculate my Zj minus Cj for x3. So what is that? CB into alpha j minus CJ. CB, you know, these are my CB, that this is my minus 2, minus 1, 0. And alpha j we have already calculated, that is this is minus 1, 3, minus 3. CG cost it is already given to us, that is minus half. So when you will solve, it is coming out to be your minus half, right? So since you have to find its optimal solution, so you can notice in this example that this cannot be your optimal. Why it is not optimal? Because the question was of maximization. The optimal solution exists if my all Zj minus Cj all are greater than equal to 0. But here Zj minus Cj corresponding to your x3 is not greater than equal to 0, that means my iteration will not stop here. So that means my this will be my entering variable. This will be my entering variable. And how do we define the minimum ratio? Minimum ratio we find xb divided by alpha j, and your alpha j should be greater than 0. For this I will not find because this is less than 0. For this thing I'll not find. That means only this is the pivot element. This is the minimum. I have to make minimum element as 1, other element as this pivot element 1, other element as 0. So when you will go for your row transformation, so now here you will get your zj minus cj. So your x1 will be on its place, your x2 vector, your x2 will be replaced by x3, and S3 will be on its place. X1 is minus 2, X3 cost coefficient you have given minus half, 0. So when you will apply your row transformation, that you will divide R3 by 3. So these entries will become 0, 1 by 3, minus 1 by 5, minus 4 by 5, 1 by 5. This entry will become 0. This will become 0 and this will become 2 by 5. And obviously you have to make this element as 0. So you will apply your row transformation on R1. That will be R1 plus mu your R2. So these entries will become your 1, 1 by 3, 0. This entry will become 1 by 3. And this entry will become 0, 0, 1. And this entry will become 1. And here you will apply your row transformation. That is your R3. R3 will be R3 plus 2 plus 3 times your new R2. So that entries will become 0, 1, 2 by 5, 1 by 5, minus 2 by 5, 1 and 0, and this entry will become 6 by 5. You will also apply your row operation. This will be R0 plus half times your new R2. So this will become 0, 1 by 6, 1 by 5, minus 8 by 15 plus m. This is minus 1 by 10 plus m. This is 0, this is 0, and this is entry is coming out to be your minus 11 by 5. So now you can stop at this iteration because all your zj minus cj are greater than equal to 0. So your when you have added your variable, so your optimal solution is that your x1 is 1, x2 is 0, and your x3 is your 2 by 5, and the z value is my minus 11 by 5. This is my optimal answer. Okay, thank you.